Hello, in this video, we'll be discussing about dynamics of rotational motion and equilibrium of rigid bodies. Note that rotational motion is a motion of an object rotating about a fixed axis. So what's the difference between translational and rotational motion? For example, I have a wrench with a center of gravity located at this point. Note that center of gravity is the point in which the weight is evenly distributed and all sides are balanced. If I'm going to apply a net external force at the center of gravity, the wrench will translate, meaning to say the object moves from one point in space to another. But if I'll attach this wrench in a bolt and try to apply force, so basically the wrench will rotate just like this one. This rotational motion is due to the presence of torque or net torque. Torque is denoted by a Greek letter tau. This is simply the measure or quantitative measure of a tendency of a force to cause or change the body's rotational motion. Or in layman's term, this is simply the rotational equivalent of force in linear motion. For example, here in linear motion, if you have an object and if you try to apply a net external force onto that object, of course that object will tend to accelerate, right? From the word itself, F is equal to ma. But here, if I have here a door, shall we say a top view of a door, and here's the pivot or the hinge of the door. If I'm going to apply a net torque to that one, that that door would tend to rotate. Okay, so the rotational analog for force is torque. The rotational analog or equivalent for mass is your moment of inertia, and the rotational analog for acceleration is alpha. This is a cross product between R and F, where R stands for the moment arm, in which it is measured from the pivot to the point where the force is applied, and F stands for force. The magnitude form for this one is RF sine theta. Again, magnitude of R, magnitude of F, and theta is the angle between your moment arm and force. And the SI unit is in Newton meter. And torque is not an energy, so we cannot equate this Newton meter to joule. And in dealing with torque, you need to define your pivot point. So since we'll be using the magnitude form of the torque, we need to assign some sign conventions. If this force 1, for example, causes a counterclockwise rotation, so the torque would be a positive value. And if this force F2 causes a clockwise rotation, well then the value of your torque is negative. As a review from your vector analysis in the previous videos is that kung mag-cross product kag duha ka vectors, the result is a vector quantity pod. And let's call this one as C vector. Ang magnitude sa cross product would be the area of this parallelogram, and at the same time, ang vector product kay perpendicular to your A and B vector. And there are another ways in order to find your cross product. It might be mugamit mo right hand rule or katong I hat, J hat, K hat nga cycle. Okay, this is only applicable kung ang imong vector kay purely lying along one axis lang. Okay, again, imong vector galay lang along y-axis, x-axis, or z-axis. So consider here a rigid body made up of a very large number of particles rotating about a fixed axis. So kanila nga particle akong gigamit. And at the same time, this is simply na-contain ni siya sa usa ka rigid body nga daghang particle. Ang net torque niya is simply equal to I alpha. Again, I stands for the moment of inertia and alpha stands for the angular acceleration. So again, I repeat, once 9 net torque ang usa ka system, meaning to say, mo rotate ang whole system. If the system is in equilibrium, then the net torque is simply equal to 0. When we say equilibrium, meaning to say at rest ang system, or pwede gatuyok pero in a constant motion, rotational motion. So there are two conditions in which in equilibrium ang system. One, your net force is simply equal to 0. So forces along x, along y, and along z are equal to 0. The second condition is simply that your net torque is equal to 0. Again, I repeat, naay duha ka situation in equilibrium ang system. One, at rest, walay rotational motion. Ikaduha, naay rotational motion pero your angular velocity is constant. So that means to say your alpha is equal to 0.